Okay, we have a question here that's aimed at upper Key Stage 2 pupils, so Year 5 and Year 6, and some might find it quite tricky. Okay, the sign below, it says, is in the shape of a rhombus. The dotted lines are lines of symmetry. And the question that we're asked is, what is the area of the sign? Now, remember that area is the flat space within a 2D shape, a flat shape. Okay, and we're asked to calculate the area. Now, the children may not yet have been taught how to calculate the area of a rhombus, but they probably do know how to calculate the area of a triangle, which, in case they've forgotten, is half of the base times the height. Okay, the height is the height or the distance from the base of the triangle. You draw a line perpendicular to the base, so at right angles, okay, up to the highest point of the triangle. Okay, so half the base times the height gives us the area of a triangle. And these lines do give us, although there's obviously 4 triangles here, but there's 2 sets of triangles that are very useful. So here's one triangle and its opposite here, divided by this line, and also we've got this triangle here and divided from its opposite here. Okay, now we can then use the information that we're given, because we can only work with the information we're given, to calculate the area of these triangles. So let's take this one here. All right, the base is, okay, the base is this, the base is 10 centimeters, and the height is half of this, because it's here. These are, remember, these are this is dividing it in half. Okay, so the height is half of this, which is 3 centimeters. Okay, and it doesn't matter how we do it. We could do 10 times 3, which is 30, divided by 2, giving us 15, or we could do we could half the base first, use 5 times 3, which gives us 15. Okay, but half the base times the height. Okay, so half base times the height equals 15, and this is centimeters squared. Okay, so this triangle, yes, this triangle, that one there, is 15 centimeters squared. If that triangle is 15 centimeters squared, then the other half, this triangle, is also 15 centimeters squared. So the area of the rhombus is 15 times 2 equals 30 centimeters squared. Okay, so we can fill that in. That's 30 centimeters squared. Let's look if we could have done this another way. We could have used this triangle here. Okay, so we'll call the first one triangle A, and the second one we'll call triangle B. We'll use this one here. Okay, so in this case the base is 6 centimeters, and okay, so the base is 6 centimeters, okay, and the height is 5 centimeters, half of this 10. Okay, the height is 5 centimeters. Okay, 5 sixes are 30, half, so half of the base times the height equals 15 centimeters squared. Okay, we've calculated that this is 15 centimeters squared. If we want to calculate the whole area of the rhombus, we need twice that. So again, 15 times 2 equals 30 centimeters squared. Okay, so that's how to calculate the area of this particular rhombus, given the information that we're given. Okay, and using what they know about the area of triangles. Okay, there is another way, all right, and this is because we are given, these are also called, you might, if you look this up, you might see that if you want to calculate the area of a rhombus, it is half of diagonal 1 times diagonal 2. These are the diagonals. Okay, so we have one diagonal and the second diagonal. Okay, one of them is 10 and one of them is 6. Okay, so it's half of diagonal 1. Okay, we'll call that diagonal 1 times diagonal 2. Okay, so that would be, okay, so 10 times 6, and we want half of that. Okay, what's 10 times 6? That's 60. What's half of that? Well, it's 30 centimeters squared. And you see, same answer. All right, so 3 ways we could have gone about this. I'm not sure if the children will have known this method, but they almost certainly will have been taught how to calculate the area of a triangle and could have used that knowledge to solve the problem either this way or this way. Thank you very much.